Hello. I do. Right, we're back on it. I've done a bit more. I've done a bit of reverse engineering. Let's just get that up there. I've done a bit of a drawing. A bit awkward with the light on it, you know. Yeah, I've done some reverse engineering. Couldn't get the information, so I've done a bit of a reverse on the connectors. Found a few things out. So I've got a few more tests to do now. I found a few more things out. Just gonna make sure I'm actually streaming. Yeah. Gotta mute that, and that's it. Set that for low quality. Set the low quality on the one I'm looking at. That's it. Right, yeah, so where did I get to? Yeah, so I've got a few more tests to do to this board now. This board here. I'm trying to find the minus 12 volts. So I found a bit more out about it. This which one is it? That was upside down, wasn't it? So it's that one. Yeah, I brought my pencil. Oh well, here's a pen. Right, so on here, this is upside down, by the way. On here, there's another connection here that goes to this coil. That gets siphoned off to a capacitor there, and there's a transistor there, and it comes all the way around to this pin here, which is supposed to be minus 12 volt. You can't see that pin, hang on. Yeah, so this transistor, capacitor, round there, round here, all the way around, feeds this LED and back to this pin here. So this must be the minus 12 volt LED. I'll just confirm that. Actually, let's confirm that. Let's see if we can see what the LEDs are. Oh, and LEDs. Hang on. Where's the LEDs? It doesn't actually show you. Oh, it does on the power supply case. Let's have a look at that. Yeah. Yeah, so can you see that? No, you can't see that. There. Let me see if I can get it in without going crazy. Yeah, it's a bit focus out. Yeah, minus 12 volt. The sink's next to it. Right. So, and that LED was, if I remember right, dim. So what I can do now is I'm going to plug PCB back, put it back in, and switch it on. Hopefully I can still get it to do a few more tests. It's going to be awkward. Will that reach up and top? Yeah, it will. Tell you what I'll do. I'll find something to go on here, so I don't have to plug the circuit board back down. We've got an ideal piece of plastic here. Yeah, that's great. So I'm going to put that on top of the piece of plastic. Let's get this up here. and plug that in. Okay, and let's just put it somewhere we can work on it. Stick it somewhere I can work on it. These two are live, by the way. This red and black, it's live. It's siphoning off 240 volts for this opto coupler switch. It's basically turning the 50 hertz into 100 kilohertz. No, 100 hertz, sorry, 100 hertz. And it's using that as some kind of sync signal for the system. So as long as that doesn't fall off, I'll be able to do some tests as well. And these are okay hanging here. Normally these large capacitors will be 400 odd volts, but on this occasion they're not, so we're okay. Right, now I've got to be able to get to it so I can work on it. That's the trouble. How can I get this to work on it? Need to bend those cables a bit. Yeah, and I've also found out which a lot of these connectors they're common. They're common, not directly there, but around the board. And I've written down which ones are common here. Look. You can't see very good. Hang on. There you go. Yeah. So some of those are common. Anyway. Right. Let's get the power back. The power back plugged in. So, at least I'm going to be able to get my meter on it. Let's go in a bit so you can see what's going on. This is the area I'm going to be interested in down here. This area here. So, as long as I can get my connections in there, let's plug the power supply in. Right, power supply is in. We're not touching any steel here, we're okay. So I should be able to switch it on. Okay. Yeah, and that one is dim. That LED there, that one there is a little bit dim. So I know for sure which one is the common now. So I'm going to swap my probe. One probe for a crocodile clip probe, I don't know what they call it. So I don't have to keep messing around with that. Alright, I'm going to have to bugger that over a bit there. Let's turn the meter on. I'm just going to check voltages for now. So we know, yeah, that one is minus 12 volts. These three are plus 12 volts. That one is ground. This one is ground. That one is ground. And these two are 36 volts. So I can plug onto any of those grounds. The safest one is that one there. Right. So I've got the ground on, and I'm going to just test this one now. Let me do it while so you can still see the meter. Minus 3.8 volts. Now that needs to be minus 12 volts. And these two over here, these are supposed to be 36 volts. They're not, they're 44 volts. Let's see what the 5 volts is like. Down here we've got 5 volts. So this one's 24 volts. That should be 24 volts. No, that's not 24 volt, is it? Why not? So we're down on the 24 volt as well. We've got our 5 volts, 5.2 volt, that's what we're supposed to have. That's good. This one here, it's 4 point something volts. One of these is a sync Yeah. Right. So we know we've got too much volts on there. Should be 36. This should be 24. We've only got 6 volts, so that's interesting. So what voltage have we got? Let's see what we've got. We've got 12 volts. We've got 12 volts. We haven't got a minus 12 volt. We've got a 12 volt supply. Now there is no load on this, so might not be giving us a proper. You'd think so, because it's switched, so it's going to have to switch itself to the right voltage, even without load, I would have thought. Right, so we've got our 5 volts there and there, both the same 5 volts, yeah. But this one should be 24 volts according to that, and we've got 6 volt, 5 volt. So we're not getting the right voltage there. Let's just try a different ground. The book does. The book does say it's got listed different returns on different pins. Yet when I measure them with a meter, they're all got continuity. So right, so the 12 volt return. So 36 volt return. Hang on, let's do the other one. 24 volts. So yeah, see, it doesn't tell you 24 volt return. So, but we'll try put it on to the 5 volt return, which would be 6 and 7. No connection, no connection. Plug 2. So really no connection there too. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got two with no connection on. So if I put this down here, for instance, that is supposed to be. You can't even see that, can you? Let's get this over a bit more so you can see it. I've moved my crock down a bit now, down to here. Let's measure. Where's the book gone? So pin 1 of PL2 connector 2. That's 6 volt. That's supposed to be 24 volt. That is. So that's down as well. So even though these voltages are down, most of these LEDs are lit up. That's not very good. It's not very good if it's not really telling the right voltage. Let's just measure the minus 12 again. Still the same. So, like I said, they're all connected now. 12 volt return on 5 and 6. So 1, 2, 3, 4. So 5 and 6. So that minus 3 volts. This is still should be 24 volts. So there's definitely a fault here. Definitely a fault. Let's just feel these because I haven't put the heatsink back on. None of them are warm or anything. Let's just measure that. Let's measure this one. What we got here? I've got 25 volts there on that reservoir capacitor. It's a 25 volt capacitor. Now this one is giving me 44 volts. So right, Right, I wanted to do some tests on this minus 12 for now. But I've got two missing voltages. I've got no plus 24 volts, and I haven't got a proper minus 12 volts. I've got the 5.2, got the plus 12 volts. Right, so here we go then. Let's try and see if I can get in without shorting anything out. Can't always see the meter. Tell you what, can I put the meter anywhere else? What about over there? It's not much space. Let's move this whole thing over a bit. Let's just move that over a bit, like that. And stick that there. That's alright. Right, got to get close to this. It's awkward with the microphone in the way and everything. Right, so I know on this capacitor here, can you even see it? It's blocking the light, isn't it? Hang on. That's too far. Yeah, there's a little capacitor there. You can't see this properly. I haven't got enough light on it. That connected in the way, really. Right, let's just measure there. That's the 3 point. You can't even see the meter. Right, so if I measure there, you get in 3.8. That comes all the way around here. Feeds this LED here. Feeds that one. It comes right round there. There's a little nick in there actually, a little nick. I got a groove in there, but there is continuity all the way up. That comes round over to here. There's the voltage back again. It goes underneath, joins up with this capacitor. I've measured this capacitor. It's about 67 microfarad or something like that. So you got your voltage again. Now it comes through there, through the other side of that. That's the, yeah, there it is there. Now just measuring the other side of this transistor. Down here, there's supposed to be a voltage down here. Down there should be a voltage. Well, if I got a voltage down there, I'm probably a bit too close to the mic. Hang on, let me smooth this mic out of the way. Let's try and swing this mic out of the way for you. Hold on a second. Yeah, getting shorter. The leads are very tiny. Right. So there's two coils on this. These are the three. Oh, can't even see. Hang on. Yeah, this coil. Where are we? Hello, still got audio, yeah. So I drew this upside down, so it's confusing. Yeah. This coil is 12 volt inductor. That's the inductor for the 12 volt. It's got two windings on it. It's got a tiny winding wound off it. This one does the 24 volt, and this one does the 5 volt. So, and this is the minus 12 volt coming around this capacitor down to there. So, and I think it ultimately goes to this, siphons a bit off there. I can't get anything off it. And the capacitor's the right way around because it's showing to the minus. The minus is going to the pin because it is a minus voltage. If it was a positive, it'd have to be swept around the other way. So I've definitely got a problem with voltages here. I've got 44 volts there. What have we got here? Nothing. Oh, I've got 44 volts there, yeah. Okay, what we got on this one? 25 volts there. 25 volts there. 25 volts there. 25 volts there. I've got a thing here saying 14.5 volts. Let's just measure that. I've got a fuse, but nothing's going on. It's a weird one. 14.5 volt this fuse says. Why would it say that? Right, I'm going to have to turn that board over now. I'll try and measure that fuse, see what voltage got on that. Alright, let's turn it off a minute. Right, I turned it off. Just got to lift this up a minute. What are we getting? Dead short. That fuse is a weird one. We're getting dead short on there. And why would you have a fuse that's touching ground? I'm sure we've measured this fuse before and it's been fine. Yeah, this fuse is fine. Minus ground 36 volts. Right. So I put the fuse back, but I can't work out why the fuse is tied to ground. Never seen anything like it. So I'm connected to ground, a touching ground here, and it's got a short, dead short, which we shouldn't have, maybe. We just say 14.5 volt there. You can't see that, can you? Yeah, 14.5 volt there, supposed to have. It's very confusing. Alright, switch it back on again. I've got no volts there with respect to ground. $25 there. 44 there. I suppose the fuse doesn't matter. It's from the ground. Doesn't matter where you put it. I suppose. Let's measure the voltage. Where does it come to? Comes from? Don't know if I did the fuse. Yeah, I did the fuse. Get a picture of the fuse. So the fuse goes all the way around to the ground. So, it's a weird one. I've never seen anyone put a fuse on the ground. Theoretically, it doesn't matter where you put it, ground or plus, still work. Anyway, it's not blown. It's just strange. So it definitely does go to the ground. Anyway, we'll ignore that. Let's see what the fuse holder says on it. I haven't got anything on there. Just say something down there. 10 amp time delay, it says. So it's a 10 amp T fuse. So it goes from the ground to where? To the main system ground, maybe. Strange. Right. So I'm missing a few voltages I wanted to just test. I wanted to test that one there. That should be giving me something. Oh, I can't reach it with this meter. Won't let me reach it. Let me just take that off. I should be able to reach it now. Right, what we got? 12 volts. We got 12. You can't see the meter now. Hang on, let me turn some stuff off. Let's turn off this USB meter, we're not using it. We're not using a USB meter, why do we need it? We're not using the scope at the minute, let's turn that off. We're not using the multimeter. USB, where is it? Not using that one, right. We're not using the ammeter either. That's it, all that gone. Right, I can see what we're doing now. Sort of, still. Can't believe I've got all this camera, but still can't see. I've got that meter that goes on the screen, I'm using this one. Fluke. It's crazy. Anyway. Well, I've got 12 volts there. Have I got anything down the side here? 0 volts there. Why have we got a 0? Nothing there. 0.93. I need to measure switching voltage, don't I? Right, let's need the scope on now. Let's put the scope back on. Microscope. No, oscilloscope. Right, let's put the scope on. Tell you what, let's edit this scope. Can I edit it while we're doing live stream? Should be able to. Properties. Oh no, properties on that. Transform. Edit transform. Right, let's make this bigger. Crop left, crop right, size. No, that's not doing it, is it? That B. Might be under the scope down there, never mind. Anyway, we'll leave that there for a bit. Okay. Right, let's get the scope on it. Where's the scope? Let's have a look. Let's get the scope on it. Here he is from last time. Stick him on another minus volts. Keyway's got the minus. Yeah, I can put him on the other side of there. Right. Okay. Let's see if we've got any signal. I'm going to go on to there. Let's need a reference voltage, don't we? Let's get a reference first. Where's my sync pin? Just find out which of my sync pins. Sync pin 1. Okay, so I should have 100 Hz down here. Yeah, still got 100 Hz, that's good. Okay, so if I go down here, well, let's go down here. Let's try this one. Got a Zener diode down there. Let's have a look at that Zener diode a minute. Measure the Zener diode. We've got 25 volts on that side of the Zener. What we got on the other side? 11 volts. 11 volts one side, 25 the other. Wouldn't it be great to have a schematic? I should go on to Sorin's discourse. See if anyone's got a schematic for one of these. So we've got 0.9 of a volt there. We've got -3 there. So I thought that was going to give me. I need to do some more tests, do some more reverse engineering of this circuit board, really. That's ground. Was that ground? No connection. 9 is 5.2 volts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's supposed to be 5 point something volts. No, that's not right, is it? What does that do? That's switching all over the place, isn't it? Let's just have a look on the scope what that is. Right. Something weird going on there. Plug 3. Sync. No connection. Polarized, yeah. PW rock. Don't know what that is. 5, no connection. 6, 7, no connection. Opt 3 is green. And 9 supposed to be 5.2 volts. Why haven't I got 5.2 volts? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's supposed to be 5.2 volts. That's not. It's not a voltage. Put the scope on, see if we can find out what it is. And Siri's got a sick machine here. I think it's just not working out without a load on it. That's weird. How can you have 5 volts over here? How can you have a good 5 volts on these two? That one and that one. Good 5 volts on them too. Yeah, this one here is supposed to be 5 volts, and you've got some weird going on. Strange. Some hell of a weirdness going on here. I remember reading somewhere that the 24 volt is switched on at request, so maybe a reason why I'm not getting my 24 volt on this one. 6.7 volt. Another 1 voltage is switched on. Now is it switched on from? Must get a signal from somewhere. Opt 3. Maybe that's it. Opt 3. I think Opt 3 must be. That there must be having to go low or high to switch on the 24 volts. Let's just measure the 24 volts a minute on the scope and just touch Opt 3. So it's just there, and if I touch that, oh yeah, definitely sent it like crazy. Yeah, so my meter's let's try it the other way around. Up 3. Measure the 24 volt. So I need to either pull that down to ground or something. Up 3, just go to resistor. Yeah, it goes to something there. It's a nightmare. Damn it. I hate it when you can't fix something easy. You haven't got enough insider knowledge to know it. You've probably got to hold that down high or low. There's no way. It doesn't tell you enough. I'm pretty sure it doesn't tell you things like that in this. It doesn't want to tell you those kind of details. PW Rock. It's not telling you. Because the 12 volt switch is on and off. Oh, the 24 volt. So let's just ignore the 24 volt for a bit. So they should have minus 12 all the time. These are discontinued. These chips here. These three here. Read the data sheet. It's big writing all over it. Discontinued. Do not use. Right. So I'm going to do this. Can't seem to detect any switching going on. None of these regulators tie in with 5 volts. None of these diodes stroke MOSFETs tie in with the minus 12 volts, but sometimes the minus 12 volts just has to be a minus 12 volt, very weak in amps. I wonder if you could convert this to a power supply. You just need that 36 volts. Put a a PC power supply on this. Wouldn't be it'd be fully switch mode, wouldn't it? But you need to get that sync off the mains to send back. It has to synchronize up with the mains. As soon as you put switch mode supply on, it's going to do its own thing. Might not matter, but if I switch that fast it might not matter. But then you're changing the design, how it was built to do certain things. Switch synchronise lighting with the mains switching. So don't we want to start messing around like that? Let's do an auto set on that. See, that's DC. These are the DC coils. I wonder if I should be able to see this switching. I don't even know if it switches. That signal just goes back as a sync, as far as I know. That definitely looks switching there, isn't it? Let's do an auto set. Let's put that on there and do it an auto. I better fasten my oscilloscope down at some point. Every time you press the button, it's so light it moves. It hasn't done an auto set, has it? 49 Hertz. So that's like AC. Do another auto set. Should have reduced that into there. Volts divide. What's it doing? Yeah, it is switching. It's a different thing. That's the trouble with this switch mode stuff. It's analog, very energy inefficient, but easy to find a problem with. That's a bit glitchy in it. Noise or whatever. Same with that one. I don't know. I'm a bit of a loss on this one at the minute. I'm not getting what I thought I was going to be getting. This switch is this transistor. It's supposed to be switching that there. I'm getting the voltage there. I was earlier, yeah, minus 3.9 volts on that end. Same with that end. And this one, can't even recognise what that transistor is. too small. I photographed it though. 31 volts. Over voltage. What's it doing? Why did I have 31 volts a minute ago? 31 volts. Oh. Got capacitor there. I'm going to have to reverse engineer this a bit more. I'm going to have to write all these components out and try and draw a schematic. I can't get nowhere with this. Right. I'm going to call it a day. And try and either reverse engineer this PCB a bit more, or see if I can get a schematic, but I won't get a schematic. Right, okay, that'll do. At least I've got a little bit further. I don't want to be buying new stuff if I can help it. Just want to repair this and that. You buy new stuff, they want you got to buy a whole old fruit machine, another one. I haven't got room for another one. I don't want another one. I just want one. So the option is to fix this one. Maybe it doesn't respond well without a load on it. I suppose I could put a bulb on it or something. Give it some load, just put a dummy load on it, a bulb. 24 volt bulb or something, or 12 volt. Just to see if it the supply pulls back up. Or go and plug it back in. Then measure it. The trouble, you can't really get your you can't get your fruit machine on your workbench. I could take the equipment to the thing, I suppose. I should have done that in the first place, but I don't want to dismantle scopes and things and meters. Right, I've got to go. I'm getting tired anyway. So that'll do for tonight. Thank you very much for watching. Very boring, but might as well stream it as just record it and upload it anyway. So it's a bit early to go to bed, isn't it? I don't know, just getting on a bit. Right then, that'll do for now, and I'll carry on. I'll turn this off before I get electrocuted. Just leave this on. You can't see that. Yeah, what I've done so far. Drew it out. That's what I've worked out so far anyway. Okay. That's the underside. Right, yeah. See you again. Bye bye.